Hey guys, this is group project for MSc 310. We have three group members, Ron, Yash, and Harpreet. So I'm going to hand over to Ron now. He's going to talk about the input.
Okay, so for the inputs, we have a folder selection option here. Then we have an option between .wav files or .csv files. And right now it's defaulted to .csv for down. And then we have the limiter set to comma. Initially it's set to tab, so you want to change that for normal CSVs. And then we have the hold button here, and you want to set that up or else nothing will show in the graph. And then I'll go over a little bit of how the program loads in the data and how it's all iterated through. So with the down mode for CSVs, it gets split into Y here and then X values here. And then with true, it does the same thing, but with .wav files. And so if you trace the Y and X values through the loops, you'll see that it utilizes a combination of shift registers to iterate over the whole data set that's loaded in. And the reason why there's 2 loops and 2 shift registers each for X and Y is because that's to implement the hold feature in properly. Okay, so now I will show a little bit of how these knobs here, amplitude, frequency, phase, and the DC offset function. So now I'm gonna hit run. And then as we can see nothing here. It's because we set an arbitrary scale for now. And then when you adjust the frequency, so you can see it. And then you can also adjust the amplitude like this. And then for phase and DC offset, you can utilize the auto scale graph feature here so you know where it's gonna be. So if you can see DC offset as 2.5, it goes to 7 there, it moves the graph with it. And then if you look at phase, it moves it to hundreds set as the same value indicated here. Okay, so now I'm gonna pass it over to Harpreet to go over these values up top here.
Okay, so as Ron had mentioned, so we are using shift register to get the instantaneous value. So for peak to peak, for RMS, for frequency, we are using the like value at that point. So it's that's why it's changing every single second. And then for the cursor, if you want to use the cursor, we have to activate the cursor button as Ron have done right now. So if you guys can see, we can as he's moving the cursor, we can see the time difference on the cursor tab, and then you can position yourself, like position the cursor with that tab. And then I'm gonna hand it over to Yash. He's gonna explain the frequency domain and stuff.
Okay, so the frequency part involved designing 3 filters. One's the low pass filter, high pass filter, and then the moving average filter. So just going to go over the block diagram for the low pass filter real quick.
Okay, we're going into it now.
Yeah. So for this, we have 4 types of filters as inputs. So depending on the input from the user, we the desired filter is selected, and the order and the cutoff frequency is selected by the user, and depending on that, the input is sent to the filter, and the output is plotted on the front panel. The same is done for the high pass as well. For the moving average filter, a window size of which is chosen by the user is taken into account to the block diagram, and depending on the window size, the moving average of the waveform is plotted. So we're just going to go over a quick demonstration of moving average first. So for example, a window size of 3 is being chosen, and as you can see, if you can just reduce the frequency a little bit so you can see the waveform. Yeah, as you can see, the white waveform, which is the moving average output, is a lot smoother compared to the initial waveform, which is the input waveform. And as you increase the window size, the averaging gets better. And now coming to the low pass filter function. So we chosen two second order low pass filter, Butterworth filter, and as you can see, as the cutoff frequencies goes up, the signal gets smoother. And then coming to the high pass filter, and as you can see, the waveform doesn't have a significant difference compared to the low pass filter. That's because this input signal that we have for this is a pretty noisy signal. So it has a lot of components that are high frequency. So even if a high cutoff frequency of, let's say, 5,000 is selected, a lot of the noise still remains in the signal, and that's why you can see the noise output. And we have two, for the additional features, that's the last part of this project. We have two additional features. One's the save as PNG output of the oscilloscope. As you can see, the two options down. Ron's just going to go and just going to demonstrate the save as PNG output once. So it asks you for a location and then saves the output of the waveform chart, and the same is done for, yeah, so that's the output of the waveform chart. The same can be done for frequency as well. For the second feature, we have a auto scale feature that sets the axis for the X and Y automatically. So if you can see, when the auto scale button is pressed, the axis limits are set automatically and then are being changed when the button is pressed. So yeah, that brings us to the end of this project, and thank you for watching.